Okay, so today we're going to look at arc length, sector area, and area of a triangle. And those 1, 2, 3 formula are here for you if you want to write them down right away, but we'll look at each one individually. Okay, so just a review of converting between degrees and radians, because we'll need to be able to do this for arc length and sector area. Remember, the circumference of a circle is 2 pi radians. So circumference of a circle means the entire way around a circle, the entire length of the outside of the circle, the perimeter of the circle, is 2 pi. So 2 pi is equal to 360 degrees, right? And if we want to convert from degrees to radians, remember we multiply by pi over 180. If we want to go the other way from radians to degrees, we multiply by 180 over pi. So just to refresh your memory, if we're converting 30 degrees to radians, you should know that one right away from your triangles, but that's pi over 6. And if you don't know it, you can always multiply by pi over 180. 60 degrees you should also know. That's pi over 3. 90 degrees should be one you have in your memory. That's pi over 2. Okay, 75 degrees, that one's a little trickier. So we'll do 75 times pi over 180. Okay, and we can divide 75 by 5. What is that? 75 divided by 5. So 5 times 5 is 25 times 3, so that should be 15. And 180 divided by 5. So 180 is 18 times 10, right? So we can divide by 5 by doing 2 times 18, which is 36. Okay, and then we should be able to cancel again. So if we divide 15 by 3, we get 5. If we divide 36 by 3, we get 12. So let me just check my math there. So we've got 75 over 180 is 5 over 12. Okay, so 75 degrees is 5 pi over 12. And then 128, same idea. We can set this up by doing 128 times pi over 180. They're both even numbers, so we can see they're both divisible by 2. So this is going to be 64. If we divide 180 by 2, that's 90. Okay, we can do that again. Divide by 2, this is going to be 32. And if we divide 90 by 2, that's, no, that's 45. Okay, so 45 is 9 times 5. 32, yeah, we don't share. Oh, 9, 3, 32, is that divisible by 3? 4, 8, no. Okay, so again, I'm just going to check my work here. We've got 128 divided by 180. Okay, oops. 128 divided by... Okay, 32 pi over 45 then. Okay, so the reason we reviewed that is because when we're finding arc length, we absolutely have to have the angle in radians. Okay, so if it's originally given to you in degrees, the first thing that you need to do is change the angle to radians. To find arc length, we're going to take this L. By the way, this is the length of an arc here. So when we're finding arc length, we're finding how long is this distance. And an arc is a part of a circle, right? It's part of the length of the circumference of the circle. So what we will do to find that is we'll take theta, which is the measure of this angle, in radians. It absolutely has to be in radians, and we'll multiply that by the length of the radius. That's all we have to do. So, so we're going to find this arc length here. Okay, so the first thing that we're going to have to do is convert 120 degrees to radians. By the way, these will be calculator questions, so we can simply do 120 divided by 180, and if you hit enter, your calculator will simplify that for you. So 120 degrees is equal to 2 pi over 3 radians. So the arc length is going to be 2 pi over 3, which is theta in radians, times the length of our radius, which is 4. So arc length is going to be 8 pi over 3, or if we want to write that as a decimal, we can do 8 pi divided by 3. And if we use a control equals sign, then it gives us a decimal. So that's 8.3, it should actually be 8.38. Okay, and then the next one, 40 degrees, we're going to convert that to radians. So again, you can do that in your head, but just to make things quicker, we can do this on our calculator. So that's 2 over 9, so 2 pi over 9. So this arc length here is going to be equal to 2 pi over 9 times the length of our radius, which is 5. So if we do times 5 times pi, and we get 3.49. So that's this one. Okay, 210 degrees, we can convert that to radians by multiplying by pi over 180. 210 divided by 180. Okay, so that's 7 pi over 6. Okay, don't forget that. You absolutely do have to convert your angle to radians. If you use degrees, it does not work to find the arc length. So the length of this arc, this entire distance, is going to be 7 pi over 6 times the length of our radius, which is 3. So if we multiply by 3 and by pi, we get almost 11, 10.99. Okay, and then we'll do one more. We've got 70 degrees, which is 7 over 18. 7 pi over 18 when we reduce that. So that's the length of theta in radians. So we'll have 7 pi over 18 times 6. Okay, and that's 7.33. Okay, and then of course, what's the last one? We haven't used 9.77. Okay. Okay, sector area is the area of a sector. It's a section of a circle, like a slice of pizza. Okay, so this is a sector. So to find that area, again, your angle, your theta, has to be in radians. Okay, so we're going to take that measure of that angle in radians, we're going to divide by 2, or in other words, multiply by 1/2, and then multiply by the radius squared. If you think about it, the area of the entire circle is pi r squared, right? So where that comes from, if you think about the entire circle, well, the measure of theta of the entire circle is 2 pi, right? And if we multiply by 1/2 and by r squared, that's going to cancel our 2, and we're left with pi r squared. So that's where the formula comes from. And so we can find the area of any sector based on this formula, as long as theta is in radians. By the way, if you're curious about arc length, this comes from, so the length of the entire circle well, I guess that's a bit more complex, but if you think about the unit circle, okay, so the length, the circumference of the entire circle, or I guess the circumference of any circle, let's go with that, is 2 pi r, right? So if you think about an entire circle, theta of the entire circle, the measure of the angle of the entire circle is 2 pi, and then times the radius, which is here. Okay, so arc length. Oh, here's a slice of pizza. So first we're going to convert our measure of our angle from degrees to radians. So we're going to have 1/2 times theta is 30 degrees, so we're going to convert that to radians, which is pi over 6, times r squared, so times 5 squared. And we want our answer to the nearest hundredth, so we'll do 1/2 or 0.5 times pi divided by 6 and times 5 squared, which is 25. And we get about 6.54. Okay. Okay, so the area, by the way, if we're going to label this, the length of our radius is in inches, so if we're finding area, it's going to be square, inches squared. Okay, so here we've got another sector here, and we want to find the area, so we're going to do 42 divided by 180 to get our theta in radians. That's going to be 7 pi over 30. So we'll do 1/2 times 7 pi over 30 times the radius squared, so times 144. So we want to multiply this by 1/2. We're going to multiply it by pi and by 144. Okay, so that gives us 52.78 to the nearest hundredth. Centimeters squared. Okay, area of a triangle. We have definitely found the area of a triangle before, or you have, I guess, in your life. We've always used the formula 1/2 base times height, right? But that only works if we're given a right angle. So if we're given a height that meets the base at a right angle. So we can find the area of this triangle, 1/2 times 6 times 7, so that's 3 times 7, which is 21 meters squared. We can find the area of this triangle very easily, so 1/2 times 4 times 7, so 2 times 7 gives us 14 meters squared. Okay, that's great, but we can only do that, we can only use that formula if we're actually given the height. But what about if we have a formula, or sorry, a triangle like this, or a triangle like this, where it's not a right triangle and we don't know the height? We can still find the height of the triangle using trig, and we can still find the area of the triangle using okay, I'll give you that formula. Okay, so the two cases that we can find the area of a triangle are if we know two sides and the included angle, and that angle has to be in between those two sides, so included. The other situation is knowing all three sides. We can find the area of a triangle. So those are the two cases where it does not have to be a right triangle, but we can still find the area of it. Okay, and how that works. So we know the area of a triangle is 1/2 times base times height, right? So here we've got a triangle, triangle ABC, okay? We can label that as triangle ABC. And this is what we want to find the area of, the entire triangle, this one. And notice the height is drawn for us here. But in the cases that we just looked at, we don't know the height. We don't know what this distance is, and we don't need to calculate it even. Because we're going to come up with a new formula based on 1/2 times base times height, but that does not require it for us to know the height. Okay, so in this case, the area of our triangle is going to be 1/2 times C, which is our base here, and our height in this case is H. Okay, let's look at sine of angle A. So we're looking at this. Remember, we can only use SOHCAHTOA if we have a right triangle. So if we're looking at sine of angle A, we have to only focus on this right triangle here. So sine of angle A, sine is opposite over hypotenuse, right? So that's going to be H over B, right? B is the hypotenuse here. Okay, and if we solve that then for H, so if we multiply B to the other side, we've got H then, right? These are going to cancel. We've got H is equal to B times the sine of A. So therefore, the area of a triangle, of this triangle, is going to be 1/2 times C will stay the same, but we're going to replace H. We're going to substitute B times the sine of A for H. And this gives us a new formula. So we've got, if we write it in an alphabetical order, we've got 1/2 BC times the sine of A. And that's going to give us the area of triangle ABC. Okay, so this is a new formula that you do not need to memorize. I'll give it to you. And even on IB exams, you won't have to memorize this for next year. Honestly, with AP, you probably won't even use it, but it's just good to be aware of. So, okay, so this is that formula, and we can solve it in a number of different ways. We can use the sides A and B, we can use the sides A and C, or we can use the sides B and C. But what's important is that the angle that we're using has to be in between those two sides. So angle C, by the way, so if this is angle C, this is angle A, this is angle B, the little side A is going to be straight across from that. Okay, side B is going to be straight across from angle B, and little side C is going to be straight across from angle C. So this first one is saying we're going to take 1/2 times this side times the sine of this angle, and that'll give us the area of the triangle. Another way to do it is to do 1/2 times this side times this side, so it's A times C times the sine of this angle. Or the third way to do it is BC, so this side times the sine of angle A. Okay, so it's always the two sides with the included angle. Okay, so finding the area of a triangle, here we've got so we're going to have 1/2 times, notice our two sides sandwich the angle. This is the included angle, so we can use, what are we actually using? We're using side C and side A, so we're actually using this formula. But it'll always be 1/2 times one side times the other side times the sine of the angle in between. Okay. And then we just calculate that. So we've got 0.5 times 11 times 15 times the sine of 28. Okay, and that gives us 22.3. I should probably check that my calculator is in, no. So make sure your calculator is in degrees. Sorry. Okay, so actually it's 38.7 is our correct answer. My calculator was in radians. Okay, so 38.7 centimeters squared is the area of this triangle. And we have to make sure our calculator is in degrees because this angle is in degrees. And unlike the area of a sector or the length of a or arc length, you can use degrees here. You do not have to change it to radians. You can use degrees, you can use radians, it doesn't matter. Okay, this was the example that was shown before, so let's calculate the area of this triangle. So we'll use 1/2 times one side times the other side, oops, times the sine of the angle in between them. Okay, and again, just make sure your calculator is in degrees. So we've got 0.5 times 8 times 10 times the sine of 49. Okay, and that's about 30 centimeters squared. Okay, and that's it for today. So thanks a lot.